this lesson is talking about the zeros of polynomials. So for number one here, we have three factors. And if I want to find the zeros, remember the zeros are the x-intercepts on our graph. So if I want to find the zeros, I'm going to take and I'm going to set all of my factors equal to 0. So I have x equals 0, x minus 4 equals 0, and x plus 3 equals 0. And then I'm going to solve those. So x equals 0 is already solved for x, so I'm going to solve the next one. So we get x equals 4, and then we get x equals negative 3. So I have three zeros or three x-intercepts on this graph. So visually, if we look at this like on a number line, we have four sections. All right, we'll call this section number 1 to the left of the negative 3. Section number 2 would be between the negative 3 and the 0. Section number 3 will be between 0 and 4. And section number 4 is going to be between or on the right side of 4. So we have four intervals where our graph is going to be doing different things. Okay. So for our intervals, the first interval is going to be to the left of negative 3, which would be everything that's less than negative 3. So x is less than negative 3. The second section would be when x is between negative 3 and 0. So when x is between negative 3 and 0. All right, and then the third section will be when x is between 0 and 4. And then finally, the section on the right side, which is all of the x's that are greater than 4. So we're going to choose a number in each of these intervals, and we're going to see when we plug that in for these factors, what the sign will be. So a number less than negative 3 will say negative 4. If I put negative 4 in for this x right here, it's negative 4, so the sign is negative. If I plug in negative 4 here, negative 4 minus 4 is negative 8, so that's negative. Negative 4 plus 3, still negative. So if I take a negative number times a negative number, I get a positive. Then I take that positive times this third negative, and the product of those is going to be negative. All right? So now we'll pick a number between negative 3 and 0. So let's just say negative 1. So if I plug in negative 1 in for x, that's negative. Negative 1 minus 4 is negative. Negative 1 plus 3 is positive. So a negative times a negative is going to come out positive. Times a positive is going to give us a positive for the product. A number between 0 and 4, let's just go with 1. So if I plug in 1 in, that's positive. 1 minus 4 is negative, and 1 plus 3 is positive. So a positive times a negative is a negative, times a positive is a negative. A number bigger than 4, let's say 5, so positive. 5 minus 4 is positive. 5 plus 3 is positive. So the product of those will be positive. Now when we talk about the product, that is literally the y value. If I multiply all of this together, it ends up equaling my y value. So when we talk about what's positive and negative as far as the product goes, we're literally referring to the y value. So my y value is going to be negative on this interval. My y value is going to be positive on this interval. My y value is negative. My y value is positive. So we're going to kind of do a rough sketch here. Now I have zeros at negative 3, 0, and 4. So I'm going to go ahead and put my x-intercepts on there. Now I have already established that the x's that are less than negative 3, that's to the left, are going to be have negative y values. So they're going to be below. So I know that my graph is going to start below, and then when it gets to negative 3, in between negative 3 and 0, I'm going to be having positive y values. So I'll be above the x-axis. Then that's going to come up here, and at some point, I don't know where at this point, it's going to curve. It's going to come back down, and it's going to touch 0, and then between 0 and 4, my y values are negative, so they will go below the x-axis. And then at some point it's going to curve and come back up and cross back over. And then when the x's are bigger than 4, I'm back above the x-axis. Now this is not a super accurate graph because I don't know where those turning points are for the relative minimums and the relative maximums. I mean, this could have gone way farther up, or this could have gone way farther down. I'm just doing a general sketch of this. So this isn't super accurate. The only thing that's really accurate is the above, the below, and where your x-intercepts are. All right, so same thing here, only this one is not in factored form, so we need to factor it. I have a common factor of 4x, so I'm going to factor out a 4x. 4x to the third divided by 4x is x to the second. 4x squared divided by 4x is x, and negative 24x divided by 4x is negative 6. So now I have a trinomial that I can then factor. I have a positive and a negative, an x and an x, and the numbers that multiply to make 6 that will subtract to make 1 are 3 and 2, and I need a positive 1 in the middle, so 3 will be positive and 2 will be negative. Then I'm trying to find those x-intercepts, those zeros, so I'm going to set all 3 of my factors equal to 0 and solve. So if I divide by 4, I have an x-intercept at 0. If I subtract 3, I have an x-intercept at negative 3. And if I add 2, I have an x-intercept at 2. So I'm going to plot those on a number line just for a visual, okay? This is just for visual purposes. Again, you have 1, 2, 3, 4 sections. Now, I did not put the factors on here in these little green boxes, so we're going to do that. So we have a factor that's 4x, a factor that is x plus 3, and a factor that is x minus 2. So for my intervals, I have less than negative 3, between negative 3 and 0, between 0 and 2, and greater than 2. So when x is less than negative 3, when x is between negative 3 and 0, when x is between 0 and 2, and when x is greater than 2. So a number less than negative 3 could be negative 4 times 4 would be negative. Negative 4 plus 3 is negative. Negative 4 minus 2 is negative. So therefore the product will be negative. A number between negative 3 and 0, we'll just say negative 2. Negative 2 times 4 is negative. Negative 2 plus 3 is negative. Negative 2, oh, this is positive. Negative 2 minus 2 is negative, and that's going to make this product positive. A number between 0 and 2, so 1, 4 times 1 is positive. 1 plus 3 is 4, that's positive. 1 minus 2 is negative, so this will be a negative product. And a number bigger than 2, so let's go 3. 3 times 4 is positive. 3 plus 3 is positive. 3 minus 2 is positive, so this product is positive. So my zeros are at negative 3, 0, and 2. So I know that to the left of negative 3, we're going to start down, come up, cross over, and then we're going to curve at some point, come back down through 0, curve at some point, and go up through 2. All right, the multiplicity of a zero of a polynomial function is the number of times its related factor appears in the factored form of a polynomial. So sometimes we might factor something and get like x plus 2 and x plus 2. That's the same thing as x plus 2 squared. That has a multiplicity of 2 because there are 2 of them. If I had 3 of the same factor, that would be a multiplicity of 3, so on and so forth. So I've given the same function here. I've just changed the multiplicity of one of the factors. So if you look at this first one, I can see that I have zeros at 1 and negative 2. So x-intercepts at 1 and negative 2. And I just have one of each of those, and it crosses over. It just crosses over and continues, and crosses over and continues at those 2 points. When I have a multiplicity of 2, so on the factor of x minus 1, which would be a 0 of 1. All right, I see that I have a multiplicity of 2. If you watch that, it's going to come down, it's going to touch at 1 and then curve back and not cross over. So we call that a turning point. So we have a turning point there. If you notice though, I don't have a multiplicity on that x plus 2, and it just crosses over and continues on. All right, so when I give it a multiplicity of 3, so my x minus 1 has a multiplicity of 3. Notice it does cross in a fancy way. It's being kind of bougie, all right? But it still just crosses and moves on, okay? It doesn't have a turning point, okay? 1 has that crossover in a bougie way. -2, I'm literally just crossing over. All right, when there is a multiplicity of 4 on my factor of x minus 1, again, it's a turning point. It's just a little flatter. It lingers a little longer before it comes back up, still just crossing at -2. So if you've made the connection, I don't know, but when the multiplicity of 0 is odd, it's just going to cross the x-axis. So if you only have 1, 3, 5, 7 of those factors, okay, then it's just going to cross the x-axis. When the multiplicity is even, 2, 4, 6, 8, 10, the graph has a turning point at the x-axis. All right, so we're going to describe the behavior at each of the zeros. So I'm going to set all of these equal to 0. They're already factored for me. We love when that happens. And I'm going to solve, so I get -4, and I get +1. So if I look when x is 0, I only have one of that factor. X plus 4, I only have one of that factor. But x minus 1, I have 4 of those. So anytime I have an odd number of a factor, it's just going to cross the x-axis. Anytime I have an even multiplicity, it is going to have a turning point. So we will cross the x-axis at 0 because I only have one of those, and -4 because I only have one of those. However, because I have 4 of the factor of x minus 1, I know that I have a turning point when x equals 1. And that's because I have an even multiplicity. All right, so we're going to set these factors on number 4 equal to 0. So x squared plus 9 equals 0, x minus 1 equals 0, and x plus 2 equals 0. So we're going to solve for x. I'm going to subtract 9. So x squared equals -9. I'm going to square root that. I have a positive and a negative answer. Now when I square root a negative, I get an I, and the square root of 9 is 3. So I get 3i. When I have an imaginary 0, that means it doesn't cross the x-axis. So there's no behavior for me to even talk about when it comes to an imaginary 0 because it doesn't cross the x-axis. So that one we're just going to kind of ignore. And then we have x equals 1 and x equals -2. So I'm not really paying attention to the x squared plus 9, so we're going to ignore that. The x minus 1 has a multiplicity of 5, so that's odd. The x plus 2 has a multiplicity of 2, that's even. So when I have an odd, it's just going to cross over, so crosses x-axis at 1. And then I look at that x plus 2. It has a multiplicity of 2, so there's going to be a turning point when x equals -2. All right, we're going to find all the real and complex zeros of the polynomial function shown in the graph. So if I look at this equation, I have a degree of 3. That means that I have 3 zeros. So in the end, I should have 3 answers. They can be all real, or I could have a real and 2 complex. If you have one imaginary answer, you will have 2. You always have an even amount, okay? So I know I have 3. Well, the only one I can see is 2. So we're going to take 2, and we are going to synthetically divide. I have 1, 1, -3, -6. Remember, that's just all of the coefficients and the constant in your equation. So we're going to drop the 1. 2 times 1 is 2, plus 1 is 3. 3 times 2 is 6, plus negative 3 is 3, times 2 is 6, and that gives me a remainder of 0. You should get a remainder of 0 because literally 2 is one of your zeros. All right, now if I started with x to the third, that means when I cut this down with a linear factor, this is going to be 1x to the second plus, and then we have 3x plus 3. Now, I already know because I can see that I have one real 0. That's the only x-intercept that I have. So if that's the only one I have, that means the other 2 have to be imaginary. So there's no point in me even trying to factor this quadratic because it's not going to. It's not going to factor. All right? So also, if I looked at it, there's nothing that multiplies to make 3 that will add to make 3. So we're going to do the quadratic formula. Our a value is 1. Our b value is 3, and our c value is also 3. So we have x equals negative 3 plus or minus the square root of 3 squared minus 4 times a is 1 times c is 3 all over 2 times a, which is 1. And then I'm just going to simplify. So I'm going to get the number that's underneath the root, the discriminant, which is negative 3. Now, I already know it's imaginary, so if I didn't get a negative under that root, I automatically know something is wrong. All right? So I see that I have a negative under the root. That's going to give me an I. So I have negative 3 plus I, and then 3 is prime, so it just stays under the root. So I squared to 3 all over 2. So that's 2 answers right there. I have negative 3 plus I square roots of 3. Left off my little negative there. Divided by 2. And I also have x equals negative 3 minus I square roots of 3 over 2. So my answers will be negative 3 plus I square roots of 3 over 2. Negative 3 minus I square roots of 3 over 2. And then let's not forget that we had one other answer, which was 2. And now you have your 3 answers. All right, this should be number 6, but I have a hard time numbering, I guess. All right, number 6, this is not 3 real zeros. I can see that I only have 1 real 0. I'm supposed to have 3 in total, which means the other 2 are going to be imaginary. So I'm going to take that 0 of 3 and I'm going to synthetically divide. So I have 2, negative 8, 9, and negative 9. Drop the 2. 3 times 2 is 6, plus negative 8 is negative 2. Times 3 is negative 6, plus 9 is 3. Times 3 is 9, which gives me a remainder of 0. I started with x to the third, and if I cut that down by a linear factor, that will be x to the second. Just shave one off, minus 2x plus 3. Again, I already know that this is not going to factor, so I will do the quadratic formula. A is 2, b is negative 2, and c is 3. So x equals negative b. B's already negative, so that would just be positive 2. Plus or minus the square root of b squared minus 4 times a is 2 times c is 3 all over 2 times a, which is 2. So we'll get that discriminant. The number underneath the root is negative 20. Then we have a 4 on bottom. 20 will split. You could do a factor tree if you want, or you can figure out what the perfect square and the prime number is that makes up 20. That would be 4 times 5. The square root of 4 is 2. And then I already know because of the negative underneath, I need an I, and then I have my square root of 5. So we have 2 plus or minus 2i square roots of 5 over 4. That will reduce. Everything reduces by 2. So 2 divided by 2 is 1. Plus or minus 2i squared roots of 5 divided by 2 is I square root of 5. And 4 divided by 2 is 2. So my answers are 1 plus I square roots of 5 over 2. 1 minus I square roots of 5 over 2. And then I also had 3 as one of my zeros. right, number 8. I see here that I should have 4 zeros in total. I only have 2 zeros showing, which means the other 2 are going to be imaginary. So I'm going to go ahead and synthetically divide by -2. Now I am missing x to the third and I am missing x, so we want to make sure that we put zeros in those locations. So we are going to drop the 1. -2 times 1 is -2, plus 0 is -2, times -2 is 4, plus -3 is 1, times -2 is -2, plus 0 is -2, times -2 is 4, and I have a remainder of 0. Now I have another 1, so I'm going to synthetically divide by the other 0 that I have, but I'm just going to take and drop what I had left over up here. So 1, -2, 1, -2. Don't bring down your remainder of 0. So we'll drop the 1. 2 times 1 is 2, plus -2 is 0, times 2 is 0, plus 1 is 1, times 2 is 2, and I have a remainder of 0. Now if I started with x to the fourth, the first time that I went through, I would have knocked that down to x to the third, and now this time I would knock it down one more time to x to the second. I don't have a term with an x, and then plus 1 equals 0. Now I'm going to go ahead and solve. So I have x squared is equal to -1. I will square root and not forget my positive and negative answer. And the square root of -1 is I. So our answers are I, -I, and then we also have 2 and -2. Number 9. Acme Innovation makes and sells lamps. Their profit P in hundreds of dollars earned, so this is going to be in hundreds of dollars, that's important, is a function of the number of lamps sold X in thousands. So we know that the profit is in hundreds and the lamps, which is the X, is in thousands. From historical data, they know that their company's profit is modeled by the function shown. The functions have zeros at -2, 3, and 10. When Acme Innovation sells 2,000 lamps, they lose $3,200. Find P, which is the profit, in standard form and interpret the key features for this situation. All right, so we have a little graph down here, and we've got a table to fill in. So we were told the zeros were -2, 3, and 10. So we're going to kind of work backwards. Like think about when you solve an equation and you have your factors, like let's say you have x plus 7 times x plus 10, and you set that equal to 0. You set the x plus 7 equal to 0 and the x plus 10 equals 0, and you end up with -7 and -10. So it wants you to say, okay, if -2 is what I got here, what was the factor? Well, all you have to do is throw an x up there and change the sign. So this factor would have been x plus 2. This would have been x minus 3, and this would have been x minus 10. So it wants me to find this in standard form. All right, this is factored form. But we only have one problem. We need to figure out if the front is supposed to have a positive or a negative sign. So that's where this little graph is going to come in. I see that I have a cubic equation here. I have a degree of 3. Now, when I have an odd degree, it's either up and then down, or it's down and then up. If you look here, this is up and then down. And remember, it's always what you end on. You're ending on a negative note, so there should be a negative out in front. So we're going to distribute this negative to the first parenthesis. That gives us -x minus 2. And then we're going to take that times x minus 3. And then once we get those two, we'll multiply that together and take it times the third one. So -x times x is -x squared. -x times -3 is positive 3x. -2 times x is -2x. And -2 times -3 is positive 6. And then we're just going to combine like terms. So we have a 3x minus a 2x, which gives us just a single x, along with our -x squared and our 6. So now we're going to take that times the third one, which is the x minus 10. -x squared times x is -x to the third. -x squared times -10 is positive 10x squared. X times x is x squared. X times negative 10 is negative 10x. 6 times x is 6x. And 6 times negative 10 is negative 60. So this is going to be our profit. We'll just call that P of x. So we have negative x to the third. 10 and 1x squared make 11x squared. Then we have negative 10x plus 6x is a positive negative 4x. And then we have our minus 60. Now, we are going to check to make sure that this equation is correct. Now, they gave you some information. They said that when you sell 2,000 lamps, you're going to lose 3,200. Well, remember, your lamps, that's in thousands. So if I say 2,000, I'm going to take off the thousands, and 2 is going to be my x value. So for the money, that is in hundreds. Now they gave you 3,200, so take off the hundreds and you just have 32. That's what you should get in the end. So we're going to check this. If I plug in 2 for the 2,000 lamps, I have negative and then 2 to the third plus 11 times 2 squared minus 4 times 2 minus 60. My outcome, if I plug all of that in, is negative 32. Well, that makes sense because it said I had a loss. I am losing money when I make 2,000 of the lamps. Okay? So, when I sell 2,000 lamps, I'm losing $3,200. So we found the standard form. Now we're just going to interpret some key features. So let's talk about the y-intercept. To find a y-intercept, we simply plug 0 in for all of the x's. So I plug 0 in for every x that I have. Might help if I use the right equation there. Minus 4 times 0 minus 60, and you get negative 60. Now remember, this is your y-intercept, and it's the money, so it's in hundreds. So add in 2 zeros. So this is $6,000. Now it is negative, so that means we're losing $6,000 when we don't sell a single lamp. All right, so before selling any lamps, Acme's production setup cost is $6,000. So that's how much it's costing me to set everything up but not actually sell any lamps. All right, let's talk about the zeros of our function. Well, I know that we have a 0 at negative 2, and I have a 0 at 3, and I have a 0 at 10, and I think that we accidentally, no we didn't, okay. So these represent the lamps sold. Well, I can't sell a negative number of lamps, so this 0 isn't even relevant to our problem. However, this would represent, now remember this is in thousands, so 3,000 to 10,000 lamps. All right, 3,000 and 10,000 lamps. And not 2. All right, so if I have 3,000 and 10,000 lamps, all right, that represents these little points on the graph. All right, those are your x-intercepts. That means that the y value is 0. Your profit is 0 when you sell 3,000 lamps and when you sell 10,000 lamps. That means that you are breaking even. You are not losing money and you are not making money. Okay? And then let's talk about where we would profit. Well, the profit is the y value. So if you look up here, any y value that's positive is where I'm making a profit. Now, this section of my graph doesn't really matter because I can't sell a negative number of lamps, and that would be anything past 0. So I am positive here This is where my y values are positive, where they are above. So between 3,000 and 10,000 lamps. So between 3,000 and 10,000 lamps, I will make a profit. All right, and then let's talk about the maximum profit I can make. Now for this, we're going to use our calculator to kind of help us with this. We want to know what this point is here because that is the maximum, which would tell us the highest amount we could make. So we're going to grab our calculator. Now it does not matter if I put in the factored form or if I put in standard form. They are exactly the same. They are just written in two forms. So on a graph, they will look exactly the same. So it doesn't matter. I'm just going to go ahead and put in my standard form, but you can put in the factored form if you want to. All right, and we're going to have to change our window here. So let's have our x's go from 0 to, let's go 12. And let's have our y's go from like -5 all the way up to 200. Now when I go to my graph, I can see right there at the top my maximum. So we're going to go to the calculate menu, which is second and trace. We're going to have it calculate that maximum for us. So we're going to choose number 4. Now it's going to ask some questions. Are you on the left side of the maximum? The answer to that is yes, I am right here. If you're not, then you would just arrow your little guy left or right. So press enter. It's going to give you a boundary line. And now it's going to say, are you on the right side? I'm not. So I'm just going to arrow over until I am over the hump here. So press enter. And then you have a boundary line. And now it's asking, do you want us to guess what that maximum is in between the boundary lines? So press enter. And he should hop up here. So you can see right here, all right, I have to sell. Now remember, this is in thousands, so you're going to have to move that decimal to 3 places to the right to give your thousands. 7,147 lamps, and then profit is in hundreds, so you need to move this 2 places to the right. 10822, so that'd be $10,822 when I sell the 7,147 lamps. So the max profit is $10,822 when they sell 7,147 lamps. All right, due to a decrease in the cost of materials, the profit function has changed. How many lamps should they make in order to profit? Okay, now to profit, that means that my y value is positive because that's the profit. So let's go ahead and graph this new equation. So we have negative x to the third plus 10x to the second plus 13x minus 22. My thing should be good. Now I'm also going to use my table a little bit here because this looks like it's crossing at 1. And it is. I have a 0 there, so 1, 0. And then this is 11, so 11, 0. So I know those are my x-intercepts. So between 1 and 11 is where I will profit. So between, now remember, this is in thousands of lamps. So between 1,000 and 11,000 lamps. All right, what are the solutions to the inequality? So when you see less than 0, you're going to think, when is y negative? Meaning below the x-axis. All right, now you want everything on one side, so it needs to say less than 0 or greater than 0. Well, I need to factor this, so I have a common factor of x, which means that would leave me with x squared minus 16. I also know that this is the difference of two perfect squares, so I can factor that into two binomials with a positive and a negative. Square root of x squared is x, and square root of 16 is 4. So I have x equals 0, x plus 4 equals 0, and x minus 4 equals 0. So we have x equals negative 4 and x equals positive 4. Now I like to sketch myself like a little graph kind of thing just to look at it. So these are my zeros. This is kind of like the very first ones that we did. So I know that this is an odd degree, meaning up and then down, or down and then up. It's positive in the front, so it should end on a positive note. So that means that this is going to go up, come down and go back through 0, and then go back up and end going positive. Now, sometimes you could have a turn in there, but all of my factors have no multiplicities. If you have a multiplicity that's even, then you would have a turn on that and it wouldn't, cross over. We don't have any of that. So we're looking for the sections that are negative, where y is below. So that would be this section and this section. So when x is less than negative 4, it's everything to the left of negative 4, or also when we are between 0 and 4. So when x is between 0 and 4. If you need to write that in interval notation, that would be negative infinity to negative 4 and 0, 4 in the parentheses. All right, same thing on this one. We are looking for when this is less than 0, so when y is negative or below the x-axis. I do have a common factor of 2x, so I'm going to factor that out. 2x to the third divided by 2x is x squared. 12x squared divided by 2x is 6x. And another 12x divided by 2x is 6. Now, I cannot factor this trinomial. So to find the zeros, I'm going to have to do the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So the number underneath the root is 12. And if you need to do a factor tree for that, you can, but it's 4 times 3. The square root of 4 is 2, so we have 2 square roots of 3. So negative 6 plus or minus 2 square roots of 3 over 2. And then everything will reduce by 2. So that gives me negative 3 plus or minus the square root of 3. Now this is kind of hard to tell where they are. I mean, you might look at this and say, oh, I don't know where negative 3 plus the square root of 3 is. So what we're going to do is we're going to put this in decimal form just so we know where this would be at on our graph. So if I take negative 3 and I add square root of 3 to it, I get negative 1.27. And if I take negative 3 and subtract the square root of 3, I get negative 4.73. And then let's not forget we did have a factor of 2x, so we're going to set that equal to 0, which means I have another 0 at 0. So if I made myself just a little graph here, I have a negative 4.73, I have a negative 1.27, and I have 0. So again, this is a degree of 3, and the thing is positive up front. So that means that we're going to end on a positive note. So we start negative and end positive. It's going to come up, go down, back through, come back up. And we are looking for those negative sections, which would be here and here. So when x is less than, and that's the negative 4.73, so negative 3 minus the square root of 3, or between this one and the 0. So when x is between negative 3 plus the square root of 3 and 0. Again, in interval notation, that would be negative infinity to negative 3 minus the square root of 3, or between negative 3 plus the square root of 3 and 0. All right, so we're going to set these factors. Well, first we need to factor them, then we can set them equal to 0. X squared minus 1 is the difference of two perfect squares. So I have a positive and a negative. Square root of x squared is x, and square root of 1 is 1. And then I'm going to go ahead and factor this back part. So positive and negative, x and x. And the two numbers that multiply to make 6 that will subtract to make 1 are 3 and 2. And that needs to be negative in the middle. So 3 will be here, 2 will be here. This time I'm looking for when they are greater than 0. So when y is positive or above the x-axis. So my zeros are negative 1, 1, negative 2, and 3. So if I drew myself a little picture, I have negative 1, 1, negative 2, and 3. Now this one has 4 zeros, so I know that this is a degree of 4 because this one has a degree of 2, this is a degree of 2. So this is an even degree, and we are positive in the front. So that means that both will be up. So we will start up, come down, turn, come back up through, then curve back down, and then come back up. Well, hit your 0 though. And end going up. So I am looking for those positive sections. That would be here, here, and here. I have 3 sections. So when x is less than negative 2, when x is between negative 1 and 1, and when x is greater than 3. So in interval notation, that's negative infinity to negative 2, negative 1 to 1, and 3 to infinity.